Hey YouTube, welcome back to the second part of the talk I gave a couple of months ago at JS Talks about different rendering techniques. Today I will dissect them, examine their workflows, pros, cons, tools and use cases, and hopefully this will be a useful guide for you in choosing the right fit for your project. For most of the approaches, I've made YouTube shorts. You can go and check them out. I've also wrote a Medium article, and I have an article on my website in which I go through all the approaches like I will do in that video. If you want to read it or see it in a short form, go check them out. So let's get right into it. The first and most basic approach is static site generation. As we saw in the first part of my talk, when I went through the history of web development, this was the first approach that emerged as the most simple one. This approach involves getting the full-fledged, already pre-built HTML and displaying it on the client. It's like preparing a feast ahead of time, and when all of the guests arrive, the food is already there and ready to be served. How the flow goes? First, you have to build the static files, and it could be either everything embedded in the HTML, or it could be into separate files depending on their size and your configuration. Then you have several options to where you can deploy them. Because they're already pre-built, you can cache them somewhere on a CDN. This way you can even further improve the performance, or you can serve them from a normal server. Then when the user opens the browser, navigates to a page and makes a request, the response is this already rendered HTML. Then the browser follows the critical rendering path. Here I'll describe it in detail so that you can follow later. Whenever you get the response, you get the time to first byte, then you start parsing the HTML, parsing the CSS, building the DOM, building the CSSOM, then constructing the tree, building the layout, and finally painting all of the elements. What are the benefits? It's super fast. This is basically the fastest approach, since here the site is already built ahead of time, and you can cache it on a CDN. So the response is quick. You get only what you have to render. So if you need it to be lightning fast, it is secure. This is kind of a moot point. But anyways, you don't have a backend, so you cannot do any exploits to the server. So I guess this is a benefit. Also, SEO, web crawlers can easily crawl it because it's already rendered and the server serves it rendered. However, the content is the same for everyone. Whenever you need to make a change, you need to rebuild the site, redeploy it, and it has limited interactivity. You can, of course, include some small amount of JavaScript, but it's no full-fledged framework that is executing throughout the app. What are the tools? You can go as simple as building the HTML by hand and embedding some interactivity if needed with some small amount of JavaScript, writing the whole CSS by hand, and so on. You could also use some general purpose static site generators like Jekyll, that is known for its simple integration with GitHub pages. And you can upload your content as Markdown to GitHub and use Jekyll to fetch that and display it. Hugo, that is known for its speed. You could also use Astro, which lets you combine different approaches, different frameworks, or you can go with some of the popular SPA frameworks that each have its own meta framework that now has capabilities of doing static site generation. So you could use React with Next.js and tell it to do static site generation. What are the use cases? SSG is perfect for blogs, documentation sites, portfolio websites. For example, your restaurant, it needs to build its website once. It may be updated only when the menu changes. So it's perfect for that because it's fast, it's SEO optimized, and the content doesn't change that often. Okay, moving on to the next approach. Server-side scripting or server-side rendering when you have multi-page applications. The page is rendered on demand on the server. Think of it as a made-to-order restaurant. Each time you order a dish, the chef prepares it from scratch in the kitchen and then serves it to you. It's freshly made, but it takes a bit more time than grabbing a prepackaged meal or a meal that was already cooked. How the flow goes? We make a request, then the server renders the page. If it needs to query the database to get some data, it does that. Then it uses that data to populate the template. And finally, it responds with the rendered HTML, CSS, and JavaScript. Again, these could be embedded in the HTML or separate. And then we follow the same critical rendering path. The picture here looks very similar or almost the same as the one for static site generation in terms of how Core Web Vitals perform. The only difference here is that the response takes a lot more time since the rendering happens on demand and on the server. Plus, we cannot do any sort of optimization like we can with the static sites by deploying them to a CDN, because here we don't have the content already built. What are the advantages here? Again, we have nice SEO because the server does the rendering, so web crawlers can get the rendered page. It's still a very fast approach. And the benefit here and the big improvement from the previous approach is getting dynamic content, because now on each request you can get data and build the rendered page, or you can use user data, or you can use the data that is changed on the database. So basically you get dynamic content here as a plus. What are the disadvantages? Here the load is passed to the server, and on each URL navigation you get a full page reload. What are the tools? All of the popular server-side languages that are used today have their own frameworks like PHP, Ruby, Python, C#, and this is one of the more popular approaches nowadays. Moving on to the maybe most popular amongst web developers, this is a single-page application. SPAs bring app-like interactivity and behavior to the browser. The client gets all of the HTML, CSS, and data and constructs the website itself. Imagine it as a buffet where you have to go and manually load your plate and go through all of the different sections of the buffet and so on. But once you have everything loaded and sits on the table, then you are ready to go. What is the flow here? First, we make a GET request, then we are returned the HTML with the shell of the application, together with all of the CSS and JavaScript containing the framework that needs to be executed. Then, if we need to, we can load data in order to enrich our page. So we can make another call to the server. The server then queries the database and returns in response the data that we can use to display. Meanwhile, we execute JavaScript and attach new elements, also attach event handlers. Finally, when we get the data, we attach new elements, we attach new event handlers, and the whole view is rendered and ready to interact with. What are the advantages here? We get dynamic and interactive content. Compared to the previous approaches where you get some amount of interactivity, here you have the full experience. You navigate between the app without refreshes. It all feels smooth. All of the components are very interactive. The disadvantages here, the initial load takes more time as the entire application needs to be executed and all of the elements created on the go, on the client. It also can be less SEO friendly. Although the web crawlers have advanced, it's still difficult for them to properly index and deal with single-page applications. They favor more statically rendered or server-side rendered page for their speed and their ready content. The tools here, I think, need no introduction. These are all of the popular frameworks like React, Vue, Svelte. What are the use cases? As we said, when you need a lot of interactivity, when you need the web page to feel like an application. For example, social networks, email clients, cloud-based tools, and wherever you need frequent page reloads that would otherwise be disruptive. Okay, so we got through the first three main approaches, and you see that from here on, we will combine them in order to use the trade-offs in our advantage in certain use cases. But as you see, the complexity will grow, and there will be some disadvantages that we would need to fight with later on. So first, we have a hydration. What is a hydration? Hydration is when the page is rendered on the server, and then in order to make it fully interactive, we need to hydrate it on the client by attaching event handlers. So think of something like instant noodles. They come dehydrated, but once you pour hot water and mix them together, they are good to go. So let's follow the flow and see where the benefits and disadvantages come in here. So when we make a request, we get the fully rendered page together with all the HTML, CSS, and JavaScript. We follow the critical rendering path, render the initially loaded page. Then we need to execute the JavaScript framework in order to go through the component tree and attach event handlers to all of the elements. So what we get here is that the first contentful paint appears faster compared to the previous approach with the SPA, because there we had to wait for the whole application to execute in order to see something meaningful for the first time. Here we get the first meaningful content, the first contentful paint faster. However, we still need to wait for the whole framework to execute in order for the app to be interactive and get the largest contentful paint. And here comes the uncanny valley where the user sees the page, it feels that it should be interactive because everything is rendered, but it isn't because the framework hasn't executed yet. So what are the pros and cons? Fast initial load time due to server rendered static content, enhanced interactivity, enriched experience after we do the hydration, better SEO because now part of we have something that is rendered on the server. The disadvantages, it gets a bit more complex compared to the other approaches because now we have to do the framework execution both on the server and on the client, and it potentially takes longer time to interact compared to the SPA, and we'll see that in a bit more detail later. What are the frameworks that support that? Again, for the popular frameworks, they have meta frameworks that support that. For React, Next, for Vue, Next, for Svelte, SvelteKit, and so on. What are the use cases? Here you have the benefits of an SEO and fast initial load times, but you also get the interactivity and dynamic content. So it's perfect for e-commerce sites, news websites, and blogs. Okay, let's continue and move forward. What will happen if you combine all of the three initial approaches? Here we get JAMstack, which comes from JavaScript, API, and markup. Continuing with our food analogies, here you can imagine ordering the food from a restaurant, but by the time it arrives, it's always cold and you need to reheat it. So here, let's see how the flow goes. First, we build the static sites like we do with static site generation. Then we have the option to deploy them to a CDN, which is a nice optimization. And then when we do a request, we respond with the rendered site that it is already rendered and cached, not rendered on demand. And we get also the JavaScript, and then we hydrate the application. So here we get the first contentful paint even faster because now we are not doing the rendering on demand, so the response should be quicker. But again, we have the uncanny valley where we see the first contentful paint and we have to wait for the framework to execute and hydrate the application before we can interact with it. What are the pros and cons? Even faster performance, high scalability because now the content is cached, enhanced security because again, we don't rely on the server that much. However, we get limited dynamic capabilities because we do the build beforehand in advance. So the initially rendered page stays the same, and we rely here on different external services in order to manage and maintain the integration between them. So what are the tools here? You can use static site generators or headless CMS in order to build the static content, and then you can use different API services that you can string together in order to bring all of the functionality that you would rather have in a single server. And then for hosting, you can use different providers that provide very specific partial application hostings like AWS Amplify, Vercel, Netlify. These are the popular ones. What are the use cases? JAMstack is excellent for websites that prioritize speed and security, such as corporate websites, blogs, and e-commerce storefronts. And it's a good choice for projects looking to leverage a microservices architecture. Okay, how can we improve upon that? Basically, we have with incremental static generation, we have the same approach, but we do the static build of the page incrementally or on some triggers. What is the food analogy here? Imagine a bakery that makes a few types of bread and pastries every morning, but also bakes new batches throughout the day as they run out, or get special orders that they do incrementally. How the flow goes here? Again, it's the same exact thing as with JAMstack. However, we have some sort of a trigger that we use to do the build. It could be either time or some data change. And the benefit here is that the initial content is more dynamic. However, still the same problem lies here, that we need to hydrate the whole application before it becomes interactive. So what are the pros here? It scales well. There's a fresh content without needing to rebuild manually the site. It combines the static site with the flexibility of a dynamic content generation. However, it gets even more complex. And as I said, you get the uncanny valley problem. What are the tools that support ISG? All of the meta frameworks have built-in capabilities for incremental builds and offer easy-to-use configuration for ISG. What is the use case for ISG? Again, the same with JAMstack, e-commerce platforms, news sites, blogs, where they have a large number of pages where rebuilding the entire site for every change is impractical. As we saw with the last couple of approaches that are a combination of the core ones, we run into the same problem. And this is hydration. And hydration is a workaround. Why is that? Because we use hydration in order to balance between a server rendered or statically rendered page that are later hydrated and basically try to get all of the benefits at once. However, the performance suffers at the end of the day. Let's look at the hydration in a bit more detail and see why exactly is that. As we saw with the initial SPA approach, we give to the client blank page that contains only the shell of the application. Then we run the JavaScript, we execute the app, we render it, and it's finally interactive. What we do by combining server-side rendered page with a single page application, we do the rendering on the server on demand. So it's slower because it's on demand and we need to get the server to do it in order to get the response. And then the response is bigger. So we get a slowdown on 2 accounts. Then we need to follow the exact same path in order to render the page. And frameworks have become better at that. And they, instead of destructing all of the elements and re-rendering them, they do a reconciliation, which means that they try to reuse as much as possible. But still, this is slower than doing the normal SPA in terms of the time it takes for the user to be able to interact with the page. So now we move to the modern rendering approaches that try to solve that problem by reducing the amount of JavaScript that needs to be executed. First, let's take a look at the islands architecture. With the islands, what is the idea of the islands architecture? The idea is that you have a mostly static page and you have some islands of interactivity. And when I first heard the term, it sounded a bit confusing to me because aren't we using hydration as a term that defines when something becomes from static into interactive? So wouldn't lakes make more sense? It's like having a big desert with some oases that you hydrate and they become interactive. I think oasis architecture would make a lot more sense to me. So this is why I don't like analogies in general. But let's continue with our food analogy. And here I would use something like tapas, where you have some small meals that you can combine together. They're already prepared. And then you have something that you do yourself on the table, like a fondue. So we get both pre-made food and food that you make on the table. Great analogies. I hope you enjoy them as much as I do. And you can expect many more food analogies from my channel. I can guarantee you that. So what is the flow here? Let's look at it in more detail. First, we make a request, we get the HTML, and here we have the statically rendered HTML. And then if we need to interact or as we need to interact with an island, then we get the JavaScript for it in order to hydrate it. Here you have the benefit that you can use different tools to build the different parts of the application. You can use one tool for static parts and two other tools for the islands. It's all up to you. However, the drawback here is that still you need to download the whole framework and execute it in order to hydrate this small part of your application. Another drawback is that islands are pretty much separate. So if you need to share a state between islands, it doesn't come out of the box. What are the benefits here? Here you get SEO, you get flexibility because you can use your framework. You also get interactivity, dynamic content. However, here you lose on state management, and you also continue to need to hydrate those elements in order to make them interactive. What is the use case for islands architecture? Well, if your site is mostly static and you just have some parts of it that are dynamic, then you can go for the islands architecture. What are the tools? You can use Astro. This is the most popular one. You can also use Quick. Moving on, in our goal to reduce even further the amount of JavaScript downloaded, we go to the React server components. Here, the idea is that you have components that are rendered only on the server, and then you have client components that can either be server rendered or on the client. And you get the benefit that you don't need to send the whole JavaScript for every component, but just for the ones that need to be interactive. The food analogy here, think of a meal where the chef sends out some of the components of your dish already prepared and ready to eat, along with some ingredients that you can cook to your liking at your table. Something like a Korean barbecue, for example. And the combination ensures that you have fresher experience and more interaction. Let's see how the flow goes, as it's not that simple. We make a GET request. Then on the server, there's a bit of a play between Next and React. We render the server components. We combine them with the client components, HTML. We stream that. We also generate a payload for the React server components. That is called the RSC payload. And then we start to progressively render the page if we do streaming. Then once we have all of the elements, we start to hydrate the client components. Here you can see we get Contentful Paint a bit faster, and we also execute less JavaScript, so the time to interactivity is even reduced. What are the benefits here? You get interactivity, dynamic content, the performance is improved. You have state management now because all of the elements share a common root. However, it gets tricky because you need to define which components are only server rendered, which are on the client, and you need to think about your application in this dual architecture. And then when it comes to hosting and executing, it gets a bit more complicated too. Ideal use cases, this is beneficial for applications that have heavy data requirements or complex server interactions, such as dashboards, e-commerce sites, or content management systems. So let's do a recap of all of the approaches, see what each brought as an advantage and as a disadvantage, how they all built on top of each other, and see what our perfect solution might look like. So with static sites, they are super fast. However, they are not dynamic and interactive. With server-side rendering, we can have dynamic content, but we don't have interactivity. Then with single-page applications, they offer rich app-like experience, but they suffer from slow initial load times. Then, when we combine SPA and SSR, the combination appears fast initially, but can result in slower overall performance due to complexities of managing both server and client rendering. Then, when we combine SPA, SSR, and SSG, we get an illusion of quicker visual rendering, but again, the time to interactive suffers. So with islands, we minimize the JavaScript that needs to be downloaded. However, the developer experience suffers because now you have multi-page applications, we have boundaries between islands, it's difficult to share state, and so on. With React server components, they offer an even faster performance, But still, here you need to consider which part of your application is going to be on the server and which on the client. The whole play between Next and React is complicated, and when we present streaming, it gets even harder. So, SPAs are interactive, what we want. Rendering on the server is fast. Hydration is bad, and we want equally good user experience and developer experience. So let's look at the following approach that we are going to examine today: resumability. Resumability refers to the ability of a web application to resume its state and interactivity on the client, picking up where the server left off without rerunning the server-side code. So imagine that you order a food from a restaurant. You don't know if it's cold or hot, but by the time you open the box and start eating from it, it's hot. And let's see by examining the flow how this would even make sense. So we first make a request. We get the server-side rendered page as a response together with all of the data serialized. And we get a really small part of the framework that is responsible for downloading only the least amount needed for each component to be interactive. So we start the critical rendering path. We start painting the already rendered page. Meanwhile, in the background, we start downloading very small chunks of JavaScript that bring us interactivity. Also, the framework can do analysis on the use of the page, so it can even optimize the order and the size of these bundles. And finally, when you need to interact with an element, for example, you click on a button inside of the header, you check if the event handler for that button is already downloaded and cached. In that case, you use it, or you download it on demand, but this is very fast since it's only a couple of kilobytes. You don't need to download the whole framework, you don't need to download the whole component, just the handler for that button. So here, the time to interactive is almost immediate, or it looks like it's immediate to the user. That's why I said that when you get the meal, you're not sure if it's cold or hot, but once you start eating, it's already hot, so you don't need to reheat it. And this is all done by keeping the developer experience as the whole framework looks and feels like React, but every component is executed both on the client and on the server. So you have the lifecycle of the component that supports that. And here you don't have that uncanny valley where the application looks interactive, but it actually isn't. What is the only drawback here? That it's a pretty novel approach. Only a couple of frameworks supported, like Quick is the most popular one, also Marco. So resumability represents a forward-thinking approach in web development, seeking to overcome the limitations of traditional hydration models by enabling applications to resume rather than reload. It promises faster initial loads and more efficient dynamic interactivity. As frameworks like Quick evolve, hopefully we finally get a glimpse into a future where we get a balance between speed, interactivity, dynamic content, and also balance between the developer experience and user experience. So as we reach the end of this exploration into the diverse landscape of front-end rendering techniques, hopefully now you know all of the trade-offs, how each of the solutions builds on top of the previous one, what are the disadvantages, the advantages, what is the flow, how it affects the core web vitals, what are the use cases, the tools that you can use to build application that follow one of the techniques, and hopefully you can better choose what option to go for your next project. Again, before saying bye, I want to mention that I have shorts for most of these approaches. So if you need to rewind and remember what were the use cases, for example, or the flow, you can go and quickly revisit each of them. Also, again, there's an article on my website and on Medium. You can go check out that. And for more front-end and web development content, check out my YouTube channel. Thank you for your time and see you in the next one.